Continuing along the day one lesson for matrices, we're going to talk about why an identity matrix is useful. We can use it to prove that two matrices are inverses of each other. So if we have a matrix A and a matrix B, and we multiply them together in either, and actually we have to multiply them together in both directions, and we get the identity matrix out, then we have found that A and B are inverses of each other. And we say that if A and B are inverses, A inverse can be denoted with this symbol, and that will be the same thing as B as long as A and B are inverses of each other. So let's go ahead and try to prove this. We're going to go into our matrix operations in our calculator. So we go to second matrix and we're going to edit. And I want to work in this case with 2 by 2 matrices. So I input 2 by 2. Then I'll go ahead and input the values of the elements of the matrix, or the entries of the matrix. So 3, -1, -5, and 2. And then I'll go ahead and quit and go back into matrices and edit matrix B. It's already set up as a 2 by 2, so I just have to change the elements. 2, 1, 5, 3. And I'll quit again. Now I'm going to go grab my A matrix and then grab my B matrix. That will multiply them together, and you see that I get the identity matrix out. I can do the same thing multiplying B by A. So grab B first, then grab A, multiply, and you get the identity matrix again. That just proved that A and B are inverses of each other. Now, why do we care about an inverse matrix? Well, let's go back to the notes here. If we have an inverse matrix, if we have a matrix A with elements A, B, C, D, then the inverse, denoted by A inverse, is actually going to be 1 divided by the determinant of A, and then multiply by this matrix where you swap the elements on the main diagonal, and then you negate the elements on the opposite diagonal. And this works as long as the determinant is not equal to 0. So we can go ahead and try to find the inverse of this matrix A in number 17 by hand. So let's go ahead first and find the determinant. Remember, we do 3 times 2 minus 4 times 1. So the determinant of A, 3 times 2 is 6, minus 4 times 1. So the determinant is 2. So I'm going to have 1 over 2. And then my matrix, remember, I'm going to swap the values along the main diagonal. So I have a 2, then a 3. And I'll negate each of the values in the opposite diagonal. So now when I multiply through by 1/2, I get 1, -1/2, -2, and 3/2. And that will give me the inverse of matrix A. Now you could also just use your calculator to find the inverse. So let's go ahead and try that. If we use, let's go ahead and edit matrix A here, and matrix A that they gave us is 3. Oops, let me input the matrix dimensions now. 3, 1. Oops, the 3 is good. There's the 1. Here's the 4, and here's the 2. Let's go ahead and ask for the calculator to give us the inverse matrix. We go to second matrix, pull out matrix A, and just hit the inverse symbol and enter, and you'll see that that's exactly what we just got by hand. The good news is we will be doing all of our matrices work with a calculator, so we could do this with the calculator. Now, if we want to prove that let's see, the inverse that we just put in, so we had put in the inverse they gave us, the 3, 1, 4, 2 matrix. We're going to go ahead now and input what we calculated to be the inverse matrix. So I'll go into my 2 by 2 matrix here, matrix B, and I'm going to put in 1, -0.5, -2, and 1.5. So let's prove that these are inverses by using matrix multiplication. We're going to take first A times B, hit enter. Look at that, I get the identity matrix. Then we need to also do B times A and make sure we get the identity matrix again. So we've now proved that we have inverse matrices, because when we multiply in both directions, we get the identity matrix. Okay, so moving onward, we're going to wrap up this lesson by just solving a matrix equation. This kind of incorporates a lot of the skills that we've learned so far, a lot of the properties of matrices and operations you can do with matrices. So here we're basically saying I want to take matrix A, multiply it by matrix X, and get matrix B. Well, the best thing to do here is to isolate matrix X because that is the unknown. So what we can do is we do left-hand multiplication by matrix A inverse. When I say left hand, notice I'm multiplying the left hand of this side and the left hand of this side by A inverse. It matters that I'm going on the left hand side of both of these because matrix multiplication is not commutative. So for example, A inverse times B would be different than B times A inverse. So we have to come in on the left side from both sides. So if I do that, and I have, this is my matrix A right here, this is my matrix X that I'm solving for, and this is my matrix B. What I want to do is multiply by A inverse on both sides. Now, if I multiply here by A inverse times A, we know is the identity matrix. And the identity matrix times X will just be X. So we have isolated X. Now we get on the right side, we're going to have A inverse times B. So basically, the matrix we're solving for is A inverse times B. Let's do this on our calculator. We're going to plug in A, plug in B, and then multiply A inverse times B. So we come over to the matrices in our calculator. Let's go to edit the first one, and we're going to plug in matrix A that they gave us, which is a 2 by 2. We have -3, 4, 5, -7, and then we're going to go type in matrix B. It's a 2 by 2, 3, 8, 2, -2, and then for the operations, what I want to do is take the first matrix A, take the inverse of it, and then multiply by the second matrix B, and this will be my resultant answer. This matrix here, -29, -48, -21, -34. Let's do that for one more problem. Recall that I'm taking this as matrix A, this as matrix B. I'm going to multiply by A inverse on both sides. Give me X here times A inverse, or equals A inverse times B. So going back to my calculator, I'm going to go ahead and let you guys type it into your calculator. Make sure you match the answer. You'll type in this 2 by 2 and this 2 by 2. Then you'll take the inverse of A times B, and you should get what's in your notes, but I'll write it down here for you. It is -51, sorry, that's hard to see, -51, 4, -29, and 1. And that is it for the introduction to matrix lesson.